Hi everyone, welcome back to the Coding and Analysis YouTube channel. And today I'm going to run the training test split with a random forest regression model for the health grade score. So the health grade score is a numerical score representing the NFL player's expected durability or risk. And I walked through in the previous video how I determined that with the simple formula and the case-by-case basis for the backups and the scores for the rookie players coming into 2025. So this data set that I'm working on, it includes the past and current season stats, like the games, played age, and health status. And then we're going to use this data set to train separate models for running backs, wide receivers, tight ends combined, and the quarterbacks. So as you can see here, we start off with this function right here. We're going to call it train and predict. So this is the core function, and it filters the data by the position right here. So we're saying filter by fantasy position. We're making a copy of the data to avoid messing with the original data frame. And then we're saying we want the features for the predictor variables. So the features will be everything in these columns up here. The age, the game's health status, serious injury, label, 2024 age, average season in games. And then the Y target variable will be the health grade. And then we're resetting the index to preserve the alignment for the rows of data. And then here we're splitting into an 80-20 train test split, making sure no test data leaks into the training. And then you can see here this random state is going to be 42. We leave it for 42 for reproducibility of the model. And then this is where we type in the random forest regressor. We imported it from the top up here. And then we abbreviate it to RF. And then we're going to put a dot fit method right here with our predictor variables and our target variable. And then the parameters for the random forest regressor, it's going to be 100. So think about it as 100 trees that it's estimating. And then the max depth is 10. So for this small data set, we're just going to use a small for max depth and a smaller amount for the number of estimators. And the random state, we're going to do 42 as well for the reproducibility. And then we're evaluating the model right here. So the predictions, the Y underscore train is predictions the model makes on the training set. And then the test data right here is the predictions on the test set data it did not see during the training. And then we're also going to evaluate the mean absolute error. So we compute the MAE for both train and test sets. Then we output the predictions labeled by the data split. And then, so we're saying right here, random forest regressor, we want the feature importance of this data frame of these features. And then it's going to show us the, based on the most prevalent by percentage, if like the health status for 2024 was the most important feature, it's going to show 60% at the top. And then if like 2023 games was like 5% feature importance, it'll show that at the bottom. So it's showing the most important features at the top, the least important at the bottom. And then we're storing our predictions right here. And then we're saying predicted health grade is training data. Train underscore DF contains predictions for the training data the model saw during the training. And then test underscore data frame contains predictions for the testing data. The model never saw this during the training. And then we're going to take the model's predictions for the training and test data, combining them into one table and resetting the index so it's clean and ready to be analyzed with the feature sets that were set up here. And then the feature sets are noted in step 2. So they're all going to be the same for the running backs, wide receivers, tight ends, and the quarterbacks. So we're going with 2023 and 2024 age and games and health status and the 2025 age. And then we're applying these features to all these, to this function that we made at the top. So we're saying train and predict. So we're using the parameter of the football position. So up here, position, and then features. So running back is the position, wide receiver, tight end's position, quarterback is the position. The features are RB features, WRTE features, quarterback features, and then we're combining all predictions into one file. So when we run the model, it's going to show the running back predictions first, wide receiver, tight end prediction second, the quarterback predictions third, and then we're rounding the health grade to 0. So I'm not going to have any extra decimals. And then we're saving it to a CSV file right here. And then this is what we want to print out in the CSV file. And then you can see here the training MAE. So think of mean absolute error tells us on average how far off our predictions are. So lower is better. So this is very low. So this is getting a really good MAE score. And then you can see here, so the training MAE is only off by like 1 point. And the testing is off by 2 points. And you can see their feature importance is 2024 health status, average season of games, and just a little bit for the 2023 health status. So these two are the most important feature importance. And then the wide receivers, tight ends, it's less than a point. The testing is 2.08 points off. Then you can see here it's the same as running back. The health status and average season of games are the top, and the 2023 health status is at the bottom. And then the quarterback, it's a little bit more off, only by slightly, so it's 2.58 points off, and the testing MAE is 3.71 points off. But you can see here it's different. It's showing the health status as the most important feature in the average season of games, and the 2024 health status is much lower for the feature importance. So in the next video, I will look through the CSV file and show which players were most correct, most players were most off with this model. So like and subscribe, and always remember to never stop coding, and see y'all in the next video. Thanks.